everyone, it's Mike Levin. Friday, April 26th at around 10:30 a.m. here at Irby, where I live. It's our playground. Our farm is around the corner, which I might show you sometime. This is our pool that'll be opening soon. And I thought I'd just start out today walking through here, because even though it's not as sunny and nice as recent days, it definitely is how I sort of gather my energy for projects that are coming up. And I'm getting ready to tackle one of my bigger transitions, one of the bigger phases of transitions from SEO to data master. And one of the recurring themes is how to collect data. And there are as many ways as there are sources of data, let me tell you. A lot of them happen to be these days available through APIs or application program interfaces provided from the company or organization that has the data. Here I am getting ready to walk out into the park area. It's the FDNY port, I guess, there. And here's the Verrazano Bridge. And this way is Manhattan, in the city. And on nice days, you can just imagine what it's like doing these walks here. Even on not so nice days, and that encourages me even more to reboot my walking, talking video series. I haven't a lot lately because, as those who follow me know, it was really because of the daily commute that made me do these videos. And in fact, it was long stretches of walk, a long subway ride and a long stretch of walk. And it was the long stretch of walk I get them in on. But that is not the case anymore. It is train, ferry, train out and train, ferry, train back. So it doesn't provide the same sort of cadence that makes these things easy to crank out. So on occasion, I'll come out and I'll just do a walk. And that's what I'm doing now, and I'm thinking through incorporating Node.js into my daily routine. Now, I'm years late to the game on Node.js, but I will tell you, I'm the person who is investigating how to do JavaScript on the server back in, I don't know, 2010, 2009, and all indications led to a thing called Helma, which used the Rhino JavaScript engine from the Mozilla Firefox projects. And it was a very different world before Node came onto the scene. And at that time, I was exposed to Python and the incredible support by, say, Google for Python, and how much it had really been an unsung hero of the industry. I gave it a chance. I fell in love with it. Now I'm a Python guy. Fast forward to 2019 and having to do Chrome automation, because one of the other ways you get data these days is by surfing the website. The web is the application, and the program interface is the web browser. And for many years, people like us were either using not a web browser to do the crawl, just to use tools like HTTP request capabilities built into Python and Perl and Ruby and such, to just do scraping projects. And there's lots of scrapers out there that work that way. Just default programming languages tend to work that way these days. But the web experience, so much more and more, has to do with JavaScript applications in the web browser. And that's fine. These are completely valid web experiences, much more interactive, and oftentimes contain a lot of data. And the data is fed to the web app with a JSON file, and you can identify the JSON data source. JavaScript object notation, a very common way to pass data around these days. You can directly import that as you would scraping a web page without a web browser, and again, problem solved. Things get complicated when the rendering of the JavaScript is necessary to populate values that only exist in JavaScript memory and on display in the web browser and not in the view source HTML code of the page. I know it's a little difficult to follow, but in long story short, you need a web browser to do certain sorts of scraping, more and more sorts of data scraping these days. And back in the old days, we had to use things like Phantom.js in combination with Firefox, Selenium. There's all these, magic cocktail mixture combinations that could give you browser-like web scraping. And they all had fatal flaws. Namely, the brittleness of it all, the being off the mainstream. And one of the things, I should really switch to a ponytail now because of this wind. This is ridiculous that I don't. One of the things that's happening right now is the mainstreaming of browser-based crawling because Google has added automated headless automation support to Chrome or Chromium. Chromium is the free and source version of Chrome. Let's see if this is actually possible. Balance the phone on a tree, on a single branch. It's probably very stupid of me. I need a better place to balance it. I'll just use the bench. This is stupid. Like that. Put my hair up in a ponytail. And continue to proudly embrace the non-edited format of my videos. I do these videos because I don't edit. And I have lots of faith that in the machine learning future that all the editing of my videos into best compilations will just be able to be done. Either crowdsourced by people with a passion or by algorithms. So I like to shoot, talk, and have faith that there's some value in it out there today, in the future. Certainly for me right now in my mind, because I'm thinking through the issue. So Chrome can be controlled by JavaScript via Node.js. So it's no different than writing a text file in, like you would a Python file, and doing Python space text file and it runs. So there's no particular marriage to a technology and Python. And the kind of stuff I'm talking about is just having an alternative to to Python scripts as a thing to schedule. It's Linux that's doing the scheduling anyway. Well, it's Linux that provides the respawner so that a Python scheduling task is implemented. The Python scheduling task can invoke anything because it does so most frequently through Python's capability to run things from the command line. So once you get something running from the command line, Linux-like type in terminal, sometimes called a bash shell. There's a lot of names for them. In fact, there's a lot of flavors of them. And the flavor that is most common in the world is a bash shell. It's more than just a command line providing the bare bones facilities of Linux. It provides a little bit more. That's where the shell gets added on to the command line. It's a shell around the basic command line. And bash, a Berkeley version of something called ash, is the one that has set in the modern world as a very standard thing. So the scheduler, which gets initiated as a Python script by the systemd facility of most modern Linux machines, that respawner spawns a python.py file, which then has all kinds of scheduling capabilities to invoke either other Python scripts or Linux bash scripts or Node.js files. So I'm making filename.js these days to do my new Chrome automation. Now, that in itself is the subject of this discussion because I like to stay multi-platform or technology agnostic as much as one can these days, and it's hard to. I got to tell you, it's not an easy thing to do. And Mac used to be my main platform, and because Macs were based on Unix, you had a standard Unix terminal shell there. Its terminal shell was a lot like a bash, standard Unix bash shell. But then to get software, Apple doesn't support the free and open source world directly, so you had to choose something like Homebrew or Mac Ports or Think, or there's a whole bunch of them, and that's part of the problem. There's no real formal or official way provided by Apple to be on the free and open source world, even once you have that coveted terminal shell, so problem not solved. I switched to Windows because the MacBook Pro 2, the MacBook, no, it's not a MacBook, it's Surface Book 2. That's what it's called. It kind of looks like a portfolio. There's a lot of devices out there. The Surfaces are just flat tablets, and I had one of those, and it barely lasted a year. I tried to use it as a laptop for work at Acronym, and it was okay, but it was it didn't last a year. It was very vulnerable to mishaps. And so on my next personal laptop, I switched to top of the line Surface Book, which sounds like it's a Surface, but it's something very different. It's a real Hail Mary hardware play by Microsoft to get just a laptop that in all respects is what Apple should have come out with. It's their most recent MacBooks, but it's touchscreen and works with a stylus, and when you use things like Art Rage on it, it's this magical platform for art and creative expression. It's convertible, but unlike the Lenovo and the Yogas and stuff that have this twist thing that goes on that's weird, the whole top comes off the screen, the monitor, and you flip it around. I think I've showed this in videos, but long story short, I'm on an awesome piece of hardware with a good enough operating system that is love-worthy as a platform more than anything I've encountered since the Amiga platform back in the early 90s. And I'm telling you, when I say that, people who know me know that's saying a lot. And that it's Microsoft is just mind-blowing. But once again, just like Steve Jobs and Apple learned all their lessons from back in those 8-bit days when Commodore was eating their lunch, they've been sinking all that commercial, consumer-minded stuff into all their latest products. And, Microsoft's been on hardware since they had the Microsoft mouse, right? This is the culmination of all that. They almost own the whole platform now, and the platform is friggin' awesome. So, to get a adequate Linux-like environment on Windows, you use Microsoft's own provided Windows subsystem for Linux, WSL they call it. It should have been WLS, Windows Linux Subsystem, but it's the Windows Subsystem for Linux, WSL. And it takes a little bit to install it, but once it is installed, it is an official, completely legit Unix or Linux Ubuntu bash shell. So it's a bash shell just like you would on a native Linux system or Unix system provided by Microsoft in this partnership with a company called Canonical, which has made the Ubuntu version of Linux massively popular. And you can do your development on it. Now, as people who follow me know, I'm also a fan of something called Jupyter Notebook to run Python in the web browser. And I've been able to use that to invoke Node.js through Python. So I needed Node to be able to run under the execution context of Anaconda's Jupyter Notebook. That's one execution context for, let's say, Python and JavaScript. It's code execution context. Everything that's needed is sort of contained within its own install using technologies like, you might call it virtualization, but it's virtual environments. It's just grouping everything with a bunch of references and pointers so that it gets all its dependencies locally. So version control of components becomes a lot easier, because each install, each virtual environment can have its own version numbers of the various components in case you require. Well, anyway, hard to make a long story short. That's one execution environment, what Jupyter Notebook provides as a result of the Anaconda install, which is highly desirable because it's the one for beginners. It's where you learn. Now, the code you write should be copy and paste pluggable into some other locations, which, for local testing purposes, for me, is the Windows subsystem for Linux, WSL. So I develop scripts under Jupyter Notebook very frequently, and then copy paste them, normally the Python code, over to Vim, the Vim text editor, which I run under the Windows Ubuntu shell. And I do things locally there, right down to like the scheduling components. You know, it doesn't have everything a pure Linux system provides, but it has most of it, and it's very similar in nature to the headless versions of Linux. You will ultimately be moving these scripts over for automated scheduled running elsewhere, where you don't have to keep your local laptop running for these scripts to trigger off. Third execution environment, much more pure Linux than the Windows subsystem for Linux, and much more Linux than Windows with an Anaconda installed to get Jupyter Notebook. So there's a whole bunch of subtleties and nuances because you're using 3 platforms and you're trying to write the code that will move smoothly from one over to the other. And because the Anaconda install of Jupyter Notebook knows it's on Windows, there's all kinds of Windows underpinnings, like dealing with the C:\/ path names. And apps are very often aware of that, of where they're loading and saving files from. It's not unwise to use absolute path names to make sure things work the way you intend. Otherwise, they have to be relative or operating system dependent. Those are 2 other choices. Sometimes you try and get operating system independence with long, absolute-looking path names, but the problem there is mappings, crazy mappings. You know, Linux has all these things like /user local bin, which Windows doesn't. So if something, you know, is looking for something somewhere, you have to have one set of paths for Windows, another set of paths for Linux. And that is not my favorite thing. Copying and pasting things from left to right to go over to automation becomes much more complex. So that's my latest tripping up point. And so what I do when I go upstairs today is fix that problem. Now, if you work relative to where your code is, it becomes much easier. And if it's a single directory within, let's say, your repo, because your repo, your GitHub repo is where your code is. So if you have one folder called screenshots, another folder called CSVs, and you know to put screenshots in one, CSVs in another. The problem arises when you're doing lots of organization and you have even just one more subdirectory of path. Now it seems like it should be easy, but now you have to choose between backslashes and forward slashes, and that's just the most simple example of the issues you start to encounter. There are plenty of others, and to solve that one, you now need to keep your subdirectory, and then your subdirectory is 2 separate discrete pieces of information, which you may pass around between program components, functions, modules, as separate parameters without a forward slash or a backslash. So you're essentially saying top directory is this, second directory is this. And then you use the programming language provided join command, which they have under both Python and JavaScript, to assemble the paths together into whatever the correct relative path is for the operating system, the platform you happen to be on. Again, we're using 3 at this moment, and that's all of them made to look significantly like Linux. But the weak point being, because you're leaning in the strength of your local hardware, which is probably a Windows or a Mac machine, you have other funky path names. And this solution I just explained about, 2 directory levels, 2 program arguments or parameters, is okay if your app is that simple. But now if you start doing more and more levels deep, you can understand how incredibly complex it needs to be, because now all your program components need to be aware of putting back together all these path names, when you could just do it by sending the whole path around, which you can't because it's very operating system dependent. Whew. Okay, so every platform, every programming language tries to provide its way of handling these. There's libraries you can get. There's the paths library for Node. So now you'd be layering in additional dependencies of having to have this package for Node, this package for Python, and it's a different, so you're always just pushing your complexity around. So when you get up to portions like this, which has a lot to do with refactoring your very career, because you just want to be able to work on the best, hardware local platform environment and not be stifled by having to work in too close of an instance to what the automated system is going to look like a headless system. I could totally just terminal into a Vim session on the server on which it's going to run and do my development work there. But where's the fun when you could be doing it locally with all the power of your local hardware, and even the power of the tools installed natively on your local hardware without using all the virtualization stuff for the benefit of elegance, reduced moving parts, speed, and just all around leading into the strength of your often proprietary tools. Nothing wrong with proprietary, so long as you make it talk nice with everything in the right places, in the right ways. So this is just a question of talking nice. How do you talk nice about path names in multi-platform development work? And that's what I'm going upstairs now to solve. I think I've got some solutions in mind that have to do with just passing around path names as list formats that'll work regardless of forward slash, backslash. I think the array-like objects between Python and JavaScript are nice enough, so maybe I can just pass around those square bracket JSON looking like lists, each one being a directory level. And programs that I write should just generically know to create a operating system specific path out of that one argument. See, the advantage is reducing what could be potentially many arguments to show where a file is supposed to be loaded or saved from, back to one argument, which instead of using controversial operating system dependent delimiters, you use non-controversial, generally universally agreed upon JSON looking lists is what we're talking about, sometimes called arrays. And using the join command on the JavaScript and the Python side to always know that argument, it could be a named argument, at least in Python. Again, I'm still learning JavaScript. But you get in an argument that has easily parsable list. The idea is you don't even need to normally parse these things. It can be loaded directly in as a memory object, so you just have a list sitting there, and then you say join the elements of this list using the join command provided by that platform, and you've got at least a path name relative to where your code is running. It's harder to get the C backslash stuff. There's these, mount directories that come into the picture a lot of times when the C colon backslash path names are mapped over to Linux, like user local bin instead of user local bin under the Windows thing. It's slash mount slash C slash username, whatever. It's hard. It's hard to remember, and it's even harder to deal with those mappings. And generally avoid them. Those are the equivalent of the absolute paths. So I think I'm convincing myself that the solution I'm going to do is going to avoid absolute paths. I'm always going to be dealing with directories relative to the repo, which has security issues, but I'm not using this for deployed websites or anything. I'm using this for scheduled tasks on private servers. So it's okay to do that sort of stuff. In fact, when I do Chrome automation, I am turning off sandbox mode of Chromium, which is generally a bad idea, but that is the state of the bleeding edge right now. If you want to run Chrome or Chromium in headless mode under the Windows subsystem for Linux, you gotta turn off sandbox mode. And by the way, part of what I've been doing is making it so that on all these environments I can do some decent debugging, and that is why I'm not just using Jupyter Notebook and the cloud server as my only two pieces, but I have that third one in the middle, which is the Windows Unix shell to test things locally. It's a good middle because it's fairly similar to the headless Linux server, and it makes me think through the issues before I copy paste from Jupyter Notebook to the .py file on the server. I get to do it on a .py file on my local machine, test things out, and shake out any path issues. So the security context stuff is fairly different. So, and you wouldn't want a web browser loading web pages in general out of sandbox mode these days. If you're surfing the web like a crawler discovering things, or if you're doing it in any network where there's other vulnerable machines around or such. But it's fine to do if you're doing it against known pages and your machine is isolated from other machines. So that's pretty much it. I mean, it is a rough edge. It's going to have to be solved. Microsoft is going to have to make sandbox kernel mode available for people like me doing this sort of stuff if they want their Windows subsystem for Linux to be taken serious by devs like me who are looking for the best combination of hardware and software to do this kind of work. Microsoft is like 90% of the way there. I had to add my own X server. This is a weird thing. To get graphics in Linux, you have to have something like, there's a few newer versions of this. I forget what the names are, but the old stuff is called X server, and it has nothing to do with what was the I guess X is gone in a lot of things now, so it's not as much confusion. But X server in the Unix and Linux world means the graphics engine to get your desktop user interfaces and stuff. Windows doesn't give that on their subsystem for Linux, so you got to add that to do the headless Chrome automation. So why graphics for headless? Because when you're debugging, you can't be running in headless mode, so you can work out all your timing issues, which can be very complex, and watch things get clicked and basically debug. So that's where I really am, because the stuff I'm trying to do right now is fairly complex in terms of automated surfing and grabbing values and waiting the right amount of time, and I need to do my testing locally on as close to the server-like environment I can get without running local virtual machines or having a primarily Linux desktop and walking away from all the proprietary advantages of Windows and Mac. So anyway, there you have it. That's how things are for me right now. And once I solve this, I have the ability to just generically scrape websites. It's a toolbox. It's a fundamental toolbox issue. Linux, Python, Vim, and Git. But for learning, Jupyter Notebook. For your main work desktop on a day-to-day basis, Mac or Windows, and for grabbing data from the web with things that don't have formal APIs or where the APIs are too expensive and you have a free web interface, Chrome automation. From that comfortable native environment with easy debugging so that you can really master this new Chrome automation capability as one of the tools in your toolbox, and projects become easier and faster. Startup cost. I'm in the startup cost of making this switch from old-fashioned crawling techniques and generally avoiding Phantom JS and Selenium to fully embracing it because it's a Google thing now. And that embracing means the embracing of Node and JavaScript, just like earlier Google's behavior had caused my embracing of Python. Who knows, maybe in the future I'll take up their Go language. But for now, it's mostly still a Python world, sprinkled in with lots of little punctuation of Chrome automation brought to you through Node.js and the Google provided material library. So thanks for joining me. Hope to see you again soon, and don't forget to subscribe.